All right, guys, today in class we talked about solving two-step equations. Okay, so there's a very systematic way that we're going to be solving our two-step equations. Just like our one-step equations, the goal is still to get that variable by itself. So we're still doing everything we can to isolate the variable so we can figure out what it is equal to. So the first thing that we need to do is we need to undo the order of operations in the reverse order of operations, okay? So if we were to solve it out, we would follow PEMDAS, okay? So PEMDAS turned into reverse order. I want you guys to think of SADMEP, okay? SADMEP. I know it sounds silly. Hopefully it sticks in your brain. SADMEP. That is the reverse order of operations. So for example, in the order of operations, we do multiplication or division first, then we do addition and subtraction. Well, when we're solving a two-step equation, what we're doing is we're taking it apart piece by piece. And so when we are taking it apart, we want to do that in the reverse order that we would solve. So we're going to do the opposite. So I want you guys to think about like if you were packing a box. If we were packing a box, the first thing that would go in with the order of operations would be parentheses. That's the very first thing we would do. So we would put it in the box first, okay? Then we would do our exponents, then we would multiply or divide, and then we would add or subtract. So since we're undoing this equation, since we're taking it apart piece by piece, we have to take out what would be on the top. So the thing that would be on the top would be our add or subtract. Then we would do our multiply or divide. So we're thinking in reverse order because we're undoing our two-step equation. Okay, so here are two examples we're going to take a look at. And just like with our one-step equation, the first thing that we're going to do is we're going to draw our line down the equal sign to remind ourselves whatever we do on the left, we then got to come over here and do on the right. To keep our equation balanced, whatever we do on one side, we have to do on the other. So if we're using our SADMEP, we're going to do our subtraction and our addition first. So I can see that I need to cancel out my plus 2. That's the first thing that needs to go, first thing I would pull out of this box, okay? So to cancel out my plus 2, I'm going to use my inverse operation of minus 2. And then whatever I do on the left, I have to come over here and do the exact same thing on the right. So we're going to subtract 2 on both sides. We have a plus 2 and a minus 2, and those two are going to cancel out. And I'm going to be left with just my 3x on the left. Then we're going to subtract. We have 23 minus 2, and we get 21. And now we have just a regular one-step equation that we know how to solve. 3x means 3 times x. So we're going to divide to cancel out that multiply. We're going to divide by 3. Whatever I do on the left, I've got to come over here and do the exact same thing on the right. We're going to cancel out our multiply by 3 and our divide by 3, and we're left with just an x, okay, which is exactly what we wanted. And then we're going to divide 21 divided by 3, and that gives us a 7. So our final answer is x equals 7. Now, an additional piece that we're going to add on today is we're going to check our work, and we're going to check our work by substituting, and we're going to substitute in our x equals 7 wherever we see an x at in our equation. Now, once we substitute it in there, both sides of our equation should be equal. If they are, that's great. That means our answer is correct. If they're not equal, then that means we need to go back and take a look at our work. Okay, so our original expression was 3x plus 2 equals 23. I'm going to substitute a 7 where the x was. So instead of 3x, I'm going to take 3 times 7 plus 2, and I'm going to see if that's equal to 23. So we know that 3 times 7 gives us a 21. We're going to take 21 plus 2, and we get that 23 equals 23. Since both of these are equal, we know that our solution, x equals 7, is the correct solution, that's our correct answer. Okay, all right, let's take a look at this one. It looks a little bit different. It is y divided by 3 plus 7 equals 12. So the first thing that we're going to do is we're still going to draw our line through the equal sign, okay? And again, we're going to use SADMEP to help us out. First, we're going to pull out our add or subtract. Here we have a plus 7. So to cancel out a plus 7 to isolate the variable, we're going to subtract 7. Okay. Whatever I do on the left, I also have to come over here and do on the right so that my equation stays balanced. So I have a plus 7 and a minus 7, and those are going to cancel each other out, and we're going to be left with y divided by 3. Over here, we're going to take 12 minus 7, and we get 5. And now we're down to a one-step equation. We know exactly what we need to do to solve. So to cancel out our divide by 3, because we want to get this y all by itself, we're going to do the inverse, which is times by 3. Whatever we do on the left, we have to come over here and we have to do on the right. So we times by 3, we're going to do the same thing on the other side. We have a divide by 3 and we have a times by 3, and they cancel each other out, and we're left with just a y. And then we have 5 times 3, and that gives us a 15. So our final answer, our solution for this equation is y equals 15. Again, we're going to check our work. So everywhere that I see a y, I'm going to substitute in a 15. So instead of y divided by 3, we're going to take 15 divided by 3 plus 7 and see if it gives us 12. Now, when we're checking, we're still using our order of operations because we're working forwards. So 15 divided by 3 gives us a 5, plus 7 equals 12. And then 5 plus 7 gives us a 12 on both sides. Since we got the same answer down here, we know that our answer, our solution of y equals 15 is correct.